Okay, these are telling us to find the area of the regular polygon with the given radius or apothem. And number 21, you say they give us the radius, not the apothem. And we're using the apothem to find these um, areas. So we need to actually calculate it out from that. If your answer is not an integer, leave it in, and notice what it says up there, leave it in simplest radical form. What does that mean? That means that you're going to be using roots and not decimal numbers, okay? Leave it in simplest radical form means you should see a radical in there if it happens to work out like that. Okay, so let's figure this out. Well, the first thing I'm going to do over here is I'm going to say, okay, if we drew that line straight down, and we had this there, okay, this angle that was formed right here is 90 degrees, okay? So that means that each smaller angle here is 45, and so this triangle right here is a 45, 45, 90. So let's sketch that down here. We've got a 45, 45, 90 triangle, and we have a 6 for a hypotenuse. And if you remember, I'm going to do this again, we need to find out what the leg is. Well, 6 is equal to x root 2 when x is the leg, okay? So how do we solve that? We divide both sides by root 2, divide by root 2, and we get, excuse me, x is equal to 6. Let me make that clear that that's a 2 over root 2, which we will then multiply top and bottom by root 2. And you will get 6 root 2 over 2 equals x. I'm going to put it here. 6 root 2 over 2 equals x. Or if we simplified that by dividing that 6 divided by 2, we would get 3 root 2. And that fits with what we know. If we took 3 root 2, the length of the leg, and we multiplied it by root 2, we would get 3 root 2 times root 2, which would be 3 times 2, which is 6, which is the hypotenuse. Okay? So we found out that x is equal to 3 square root of 2. Okay? What is that x length? Well, that's the legs of this triangle, which if you look up here, that's this length right here, the apothem, or this length right here. Okay, and there's multiple ways to find the area for that. You can say, and let me erase all of these marks. You can say, okay, well now what do we know? We know that, excuse me, we know these lengths are, this is equal to 3 root 2. And then that tells us then what our side length is. Well, if that's 3 root 2, then this is twice as long, 6 root 2. Okay, so for an area for this triangle, we've got a perimeter. The perimeter, remember, is the side length, 6 root 2, times however many sides there are, 4. So the perimeter is equal to 24 root 2. And so if the formula, and by the way, I'm just going to put that perimeter up here, equals 24 root 2. And again, just to be clear, we got that by saying we found by using special triangles that this is 3 root 2. And since these are equilateral, this is 3 root 2 here, from here to here. And double that is 6 root 2. So now we know the side of one, length of one side, and we can times it by 4 to get the full length. So the perimeter is 24.2. So if we do the formula for area of a polygon, area is equal to 1/2 the apothem length, which is 3 root 2, times the perimeter, which is 24 root 2. And if you know about radicals, you will know that this root 2 and this root 2 multiply together to be 2. Root 2 times root 2 is 2. So then you've got 2 times 3 times 24, the coefficients. And when we do that on the calculator, we've got all that multiplies together to be 72. And the area of this is 72, and they give us the units as centimeters, so the centimeter squared will be the units because it's area. Now for number 25, I'll do the work up top, but the first thing I'm going to do is I'm going to draw an apothem here. Okay, and I'm going to draw this little triangle. We say this is that blue apothem, and this right here, they gave us that radii of 6 root 3. Okay, 6 root 3. No, I'm sorry, that's the hypotenuse of 6 root 3. So that means that the shorter leg would be 3 root 3, because it's always half of the hypotenuse. And we always take that shorter leg, 3 root 3, times root 3, to be equal to the long leg. So you always do short leg times root 3. And what is 3 root 3 times root 3? 3 root 3 times root 3. These two root 3's go together to be root 3 times root 3 is 3, times this 3 is 9. So that makes this length 9. And now we know the apothem is 9. Okay, so we have an apothem of 9. And let me redraw it in there. Okay, and we found out that up on this drawing up top, that this short leg was 3 root 3. And since it's double from 1/2 of it here to get the whole side length, right? Then the whole side length is 6 root 3, which makes sense because if this is a hexagon, and it is, then we're getting equilateral triangles when we draw all of these. Okay? So sorry about that. I'm erasing all my lines. So this becomes 6 root 3, and the apothem was 9. So what's the perimeter then? The perimeter is going to be 6 root 3 times how many sides there are? There are 6. So we've got a perimeter of 36 root 3. So if we write the formula, the area is equal to 1/2 the apothem length, which we found to be 9, times the perimeter. And again, remember, if we found that this is 6 root 3, then the whole thing is 36 root 3 because there's 6 of those sides. We've got 36 root 3. And when we multiply all that together, I'm going to keep it as a radical for now. Well, I'm going to keep it as a radical at all because they told us to. 9 times 1/2 times 36 equals 162 root 3. And what are the units? The units are meters. So it's meters squared. That's the area. And finally, let's do this triangle over here. This is actually an interesting one. Check it out. If we have 3, I'm going to draw these dotted lines like that. What does that break each one of these angles up into? It breaks them each up into 120. Okay? These angles. So if we drew an apothem straight down, that. So we've got 90-degree angles there. Well, if they were 120, now we've got a measurement in here of 60. And that's then 30. Okay? So what are we dealing with then? Well, if we know, basically, if they gave us that 4, see that 4 that they gave? 4 that they gave us there, that's the hypotenuse length right there. So I'm going to redraw that triangle out here like that. That's this triangle. Okay, to say that if that length here is 4, then this short leg across from the 30-degree is 2. That gives us an apothem of 2. And then what is this other side? This is 2 root 3. That's what you get in the 30, 60, 90. And what we're saying there then is this length is, this length is 2 root 3, which gives you a full side length of double that, 4 root 3. So I'm going to erase this. We've got an apothem of 2. Apothem of 2, and a full side length then from here to here of double that amount, or 4 root 3. Then we can write in our formula. We can say the area of the full thing is equal to 1/2 the apothem length, which is 2, times the perimeter. And if the whole distance around, well, if one side is 4 root 3, then the whole distance around is 12 root 3 because there's 3 sides. Okay, so doing these two first, 1/2 of 2 is 1. So 1 times 12 root 3 is just 12 root 3. And what are the units? The units were inches, so it's inches squared. And that's what we get for our answers. Hopefully that made sense. It's really about, in this case, using special triangles for these three and knowing what the measurements we get. And that's why you can put it in simplest radical form, because all of these are special triangles, and special triangles will give you lengths that involve radicals. So there you go. Ask me any questions if you have any.